Well, hello students. This is Mr. Rich. I'm going to work a problem that a student asked me to work in one of my Q&As about AP Calculus, and it is solving a differential equation. Here is the problem. It says the quantity R in grams of a certain radioactive substance decreases according to the exponential decay model, dr dt equals negative 0.05 R, where t is measured in seconds. During an experiment, a scientist determines that the rate of decay of a second substance with the quantity S in grams can be represented by a linear model, ds dt equals negative 4, where t is measured in seconds. Then they give me the values here at time t equals 0 for both substance, the first substance R, quantity R, and the second one S, but 100 and 125. So what I'm going to do is I'm going to solve both differential equations. I will start with the dr dt. So we will write dr dt is equal to negative 0.05 R. To solve this, I'm going to separate the variables. So I'm going to put the dt over on the right side. It's going to look like this, times dt. But I'm also going to divide by r to bring the r over with the dr. So it's actually going to be negative 0.05 dt dr over r. Well, as we solve differential equations, we're going to integrate both sides of this equation. And when I do that, on the right-hand side, I'm going to get 0.05 t. And when I integrate dr over r, what we get is the natural log of the absolute value of r. And that would be equal to then the negative 0.05 t. And to solve for r, we're going to exponentiate. So that's how we get rid of our natural log there, is raise e power on both sides, called exponentiate. That's going to leave me an exponential decay, where I'm going to have an initial value, I'll call it big C, and that would be C times e to the negative 0.05 t. Now I know what that constant C is going to be because they told me the initial condition at time t equals 0 for that substance was going to be 100. So I do know the solution to the differential equation. It is 100 e to the negative 0.05 t. The other substance, this is its differential equation right here. When you solve that one and you separate the variables, you get ds is equal to negative 4 dt. If I integrate both sides, I'm going to get s is equal to negative 4t plus c. They did tell me the initial amount of material was 125. So when I stick 0 in for t and 125 for s, I understand that this now is the equation here. So here are the two solutions to the two differential equations that we started with. And this is asking me at what time t in seconds will there be equal quantities of both substances. So what I want to do then with either my TI-84 or Desmos, I want to graph those two functions and see where they intersect one another. Now, if you're doing the AP exam in May 2025, then you will be doing your exam in the Blue Book app, the Board Blue Book app. You'll be delivered all of the questions in Blue Book. Your free response questions will still be written in a booklet, so you'll get it manually graded by the graders. But when it comes to the calculator active portions of both the free response and multiple choice, you should have access then to Desmos, the graphing calculator, because that's embedded in the Blue Book app. So I'm going to do it and show you how this would be done faster in Desmos, but then I'll switch over and do it in the TI-84. So here, what I'm going to do is graph our first one, which was our exponential decay, which was 100 e raised to the negative 0.05x. And you can see how much faster it is to be entering in these functions than it is in the TI-84. So I have graphed the exponential, and I double check to make sure I put that in right. Here is the linear, negative 4x plus 125. I need to zoom out, and here's the intersection point of these two functions. So it looks like at time 23.548 is when they are going to be the same amount, the amount being 30.8. But now it is asking us here, I believe, for the time, right? It wanted the time in seconds, and you can see 23.548 is going to be our answer. If you had to do this in on the TI-84, which honestly I don't recommend it, right? But if you did, because like say by some chance they don't have Desmos activated in Blue Book while you're taking this exam, which I don't know why they wouldn't, but you never know. Then what I would do is I would go into y equals. I'm actually in polar mode right now, so I need to be in function mode. So when I hit y equals, I'm going to put in my first equation, 100, and then I have to hit e. So you can see how much slower this is for me. So 100 times e to the negative 0.05, and I will use x as my variable. I will come down to y2, and I will put in the linear decay, which is negative 4x plus 125. And what makes Desmos so superior to graphing on the TI-84 is that I have to set my window here. I look at my times, and the times go from to 25. So I'm going to set my window to go from 0 to 30. And then I got to set my Y window. Well, the decay, the exponential decay is starting at 100. So I think I can just get by with going from 0 to 100. And I should then see the intersection when I graph these two. Now, I have a prior stat plot there. We'll ignore that. But that is the intersection point. But whereas in Desmos, I get to click to find out what the intersection point is. Unfortunately, can't do that here. I have to do second function calc, number 5, intersect, hit enter twice. I will scoot my cursor close there to help the algorithm. And there you go. You can see that X is 23.548 while Y is 30.808. And there is my answer, letter C. All right, hope that was helpful. I'll see you in the next video.